Okay, so every AWS Lambda explainer I've probably ever read has always started and finished the exact same way. AWS Lambda is a serverless platform that allows you to run code remotely, da 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 da. And honestly, when I read that, I just close the tab. It doesn't make sense and it's not helpful to me at all. So, what I'm going to do is break down AWS Lambda into a really simple and easy to understand explanation. And next time someone asks you what is AWS Lambda, you don't have to just go and regurgitate what the website says. You can actually be able to explain it. But before we actually get into the explanation, just so you know, I do have some credentials. I'm a software engineer working at AWS at the moment. I use Lambda, to be honest, not that often as I'm more working on the front end, but I do use it in my job, and today I'm going to break down exactly what it does. Alright, so as you can see, I've got a little diagram for us here, and there's quite a bit to get through, but I'm going to make sure every second of it is worth your time. Not a second is going to be wasted. So, normally, and if I want to give a one-line explanation of what AWS Lambda truly is, it's pretty much AWS Lambda says, just give me your source code, I'll put it on the cloud, I'll provision the servers, I'll do the patching, you just tell me when you want to run that code, and I'll run it for you. That's basically, in a nutshell, what AWS Lambda is. So usually when you want to have some code running on the cloud, the old way, and the way that some people still do it today, is you'll rent a server, you'll install Linux on the server, you'll install a runtime, you'll write the web server, you'll write the code. And when you're writing a web server, you're not just writing the code like your business logic, you're writing everything to do with the server. And that can be really painful and take a lot of time, and it's also quite hard to maintain. You have to manage all the processes on the server, you have to manage your SSL certificates, you have to do logging and monitoring, all of that, which that's all on top of your business logic, which already takes a lot of time to run. And another big thing with the old way of doing it, which is running a server, physically having a computer where your code runs on, in your house, in your garage, is that it's running all the time. So let's say, I have a startup, and my one user hits my page every day. Once a day. My servers are running 24/7, so it doesn't pay for me to have the server up 24/7 when even my 3 users are hitting my page once a week. So that's the old way of doing things. And like I said at the start of the video, Lambda's promise is just give me your code, I'll run it only when there's a request, and I'll handle the hardware, the OS patching, the scaling, the availability, and when no one's hitting your server, I'm not going to charge you. I'm only going to charge you when I run. And Lambda is really simple. It's quite literally take a function, take a bit of code, give it to Lambda, you upload it, you own the function, and Lambda handles everything else. Okay, so I said the Lambda runs whenever I tell it to, but how do I tell the Lambda to run? I mean, fine, I've got my function on there. In this case, my function literally just returns hello world every single time. But how do I get this function to run? I mean, that's a good question, right? And there's tons of different ways for you to basically invoke your Lambda. So I've got a couple of examples here, and there's 200 or so different ways you can invoke a Lambda. But for example, an API request could come in. The API request hits your Lambda detects it. Let's say there's some form data, a user submits a form. Your Lambda grabs that information from the form and then executes some code, potentially saves it to a database, sends you an email, something like that. Or the Lambda can detect when a file is uploaded to an S3 bucket. So let's say a user uploads a file, maybe they want like a thumbnail generator or something like that. A user uploads a file, the file goes into the S3 bucket, Lambda detects that there's a new file in the S3 bucket, it grabs that file, it processes it, it potentially saves it back to the bucket, saves it to a database, things like that. Similar thing with queues, we've got SQS queues, where the Lambda polls the queue and grabs things out of it, and then it processes that. Or we could literally have the Lambda running like a cron job. Every 6 a.m. it runs, it grabs the latest news article and sends you an email with it. Additionally, we could also, so as you can see, there's tons of different ways for the Lambda to be invoked or awoken. But it can also detect when DynamoDB rows change. So let's say a row gets removed. We could grab that row, save it to S3, and then move on. So there's tons of different ways for Lambda to be invoked, and that's your code in your Lambda can will detect how was I invoked, and based off that, execute code in a certain way. Okay, so now let's actually walk through a physical example, right? So let's say an event comes in. Let's say a file gets uploaded to the S3 bucket. An event comes in over here, and there's two situations now. Either the Lambda can be warm over here, or it can be cold over there. And so what is a warm environment and what is a cold environment, you might be asking? Well, a warm environment is an environment that has already been set up and is already running. So when a Lambda runs, it installs all your dependencies that your code has. It builds the environment where the code will run. It does quite a few different things, installs dependencies, builds environment, things like that, right? And that takes quite a bit of time. And usually, if your Lambda hasn't been invoked in a while, that's a cold start. It needs to build the dependencies, get the environment ready, get your code ready to run, and then run your code. See, that would be a cold start because it had to do all these different things that are listed here. But let's say an event comes in, and then another event comes in. The Lambda doesn't need to do all of this again. It's the same code. It's in a warm environment now. The Lambda hasn't gotten written all of this yet. So if it's a warm environment, the request time is much quicker because the event comes in and then it's immediately able to be processed because we don't need to set up all of this again and again and again. And that's okay. Let's carry on through our example, I guess. So the environment is cold. We ran the code. Now we've got a warm environment. So when another request comes in, it'll go to the warm environment step, runs instantly. And then after it finishes, the Lambda keeps the environment warm for maybe a couple of minutes or maybe an hour. So what that means is that it won't tear down the environment. It'll keep it there. So if another request comes in, it's a warm start and we have a much faster execution time. So I already talked about some examples, but if we want to go a little bit deeper into what like kind of stack would look like, let's just go through one of these. It could be a backend API. It could be used for backend API. So we could have an example where there's a Lambda and an API gateway. So API gateway kind of hosts your API. So when a request comes in for adding a user to your database, it hits the API gateway. API gateway invokes the Lambda, and then the Lambda processes that information in the request, creates a user and saves it to a database. That's just an example, right? But there's tons of different things that we are able to do with Lambdas. So like I talked about before, there's file processing where it goes into the S3 bucket, Lambda grabs it from the S3 bucket, changes it, saves it back. Or Lambda can be used to connect two services together. So let's say two Lambdas need to communicate with each other and there's like another service. The Lambdas are able to transform the data between this service and this service so that it's in the same format, for example. So the Lambda is kind of like a middleman. And then schedule jobs like we talked about before, using Event Bridge to keep the Lambda running at a constant rate, like every 6 a.m. Bring me my news articles, you know what I mean? So that's kind of the use case of Lambda and how it works. And two things which are pretty important, but not the end of the world, especially at the start while you're just learning, is the pricing. So the way you charge for Lambdas is the number of invocations, so how many times it's called, how many times a request comes in and it's processed, and then also the duration times the memory. So how long the function ran for multiplied by how many gigabytes of RAM you had allocated to the Lambda, if that makes sense. So in the free tier, we've got a ton of free invocations and memory, so not really the end of the world there. And there's a couple of other limits, not that us people who are new to Lambda would ever really run into, but Lambdas can't run for more than 15 minutes, and they are fully stateless. So what that means is that if you create a variable in a Lambda, and then in the next invocation a new request comes in, you try to access that variable, you're not going to be able to. It's going to have reset. So normally what you do is if you want to save a variable, you'll save it into DynamoDB, and then the next time the Lambda runs, it will go fetch that. So basically that's what it means to be stateless, right? And then to prevent cold starts, you can use something called provision concurrency, which is where we are able to keep Lambdas warm for longer than an hour, for like days, and then we know that a certain amount of requests coming in will always get a warm environment. So with that said, let's quickly go build a Lambda now so I can show you exactly how it's done. It's very simple. Alright, so let's quickly go through how you would actually create your own Lambda, right? So I'm on the AWS console. I've just created an account. It's pretty simple. Didn't even have to add my card details. And now we're on the AWS Lambda console and we're going to go create a function. So let's go create a function. We're going to author it from scratch. There are blueprints in the case where you're reading from an S3 bucket, so they kind of help you out, for example. But we're just going to create from scratch. We're going to name it my function. And we'll keep it in Node. It doesn't really matter though. And then, so Node is just JavaScript. And then there's a bunch of different settings here, but we don't have to worry about any of these, especially for example. But if you want to learn about them, the docs are actually pretty useful for these, to be honest. The actual Lambda docs are terrible, but the settings of the Lambda docs are great. So I'll just go create function. It's quite literally that simple. And let's just let it load. Can take about a minute. You can also create a Lambda from a container image, but I won't get into that. So now we've got our function, and we'll just dismiss this. So a Lambda it's got one main function, and that's the handler function. So the handler is the function that gets invoked when the Lambda is called. And it's always past this event object. So the event object will contain any relevant information. So let's say if it's from an S3 bucket, it would contain the S3 bucket name and the S3 bucket data and things like that. But in this case, it's going to just be a simple event. And all we're going to do is, see, this code's already here for us. And I'm actually just going to use this as an example. So we always need to return something. And in this case, we always need to return JSON. And in this JSON, we're just going to return states of 200 and this JSON over here. So usually what would happen is, if this was what we were returning, an API gateway, so a user would hit your API gateway would forward your request to this Lambda. The Lambda would, using the event, process the request, figure out, is it a GET request, is it a POST request, to what resource are we posting or getting from, and then it would maybe query DynamoDB, get some data back, and then create a JSON object and return the JSON object, and then API gateway would give that to the user. So in this case, we don't have API gateway, so that's fine for now. We can just go test, and we'll just create a new test event, testing, and in this case, it's not really expecting anything. Reason I'm saying that is because no matter what the event contains, we're always just returning hello, I think it was. So let's give it an empty event, and we'll go test. So as you can see, success, and then this is what the Lambda returned to us. So what happened is our empty brackets, we could have had anything in there, right? Was given as event here. Event was used in our code. Okay, we didn't actually use event, but event could be used in our code and processed respectively. So I understand this is really high level, and that was kind of the point of this video. But if you guys want to go in depth, if you want an in-depth video of me building out a service or something like that using Lambda, API gateway, S3, all of that, then let me know. I'm keen to do that, and I've done it quite a few times before, so I think that could be a really interesting tutorial. But for now, this has just been a high-level overview. I hope it's kind of made sense to you and kind of simplified a few things. I really recommend you read the blog that I wrote. I'm going to put it in the description down below. It's kind of this video in a text format, but maybe a little bit more context and a little bit of things I missed when I spoke. But yeah, other than that, have an amazing rest of your day, and yeah, see you guys in the next one.